Greetings everyone, through here. Large language models has taken the industry by storm, pulling together this series of lectures to orient around key concepts of large language models. This will be a comprehensive set of videos cut into chunks and released throughout the next couple of weeks around large language models. For most users, the entry to a large language model might be a ChatGPT. But this is the tip of the iceberg. If I draw an iceberg, this is the ocean. GPT-4, ChatGPT will all be on the tip of the iceberg. Now, while it's underneath the ocean, there is tons of tools, innovation happening, and we want to make sure we surface those all up. The next things that we start seeing beyond the GPT and the ChatGPT would be something like a vector database. What is a vector database? What does it mean? Where is it used? We're going to unpack that. Embeddings. What is an embedding? Embedding algorithms, prompting, prompt engineering, semantic search, which applies to vector databases. Where do we leverage in semantic search and why? Transformers. Very important to understand transformers or what transformers are. Neural network. What is a neural network? Fast searching algorithm from Facebook, Haystack, LangChain, LLMOps or Llama Lab, Llama Index. What is that? How is it being used? Tick token, encoding, LLMOps, generative Q&A, prompt templates, agents, memory. There is GPT index and more. This is all leading to a space that the industry hasn't really crystallized yet, but there is tons of conversations around this. This space is LLMOps. It borrows from the software engineering space, DevOps. There was a data ops, ML ops, and now the industry is crystallizing this concept of the LLM ops. How do you not just leverage large language models like the ChatGPT, but how do you integrate and build that into an organization? What does that architecture look like? A lot of questions that people are asking. Do I really need a vector database? If so, why? Where do we do a semantic search? This is a rich ecosystem. In this lecture, we're going to unpack the different pieces and the different concepts within the large language model operation space. In this lecture, we're going to talk about the key capabilities of OpenAI, how they relate to large language models, how they differentiate from the previous way in which the average user interacted with knowledge and knowledge discovery. If the box we have here on the screen represents OpenAI's capabilities, there are a couple of areas to call out. First would be the GPT, Generalized Pre-trained Models. GPT is an API. You can interact with that API and get results. Now, GPT has been around for a while. It started with GPT-1, GPT-2, GPT-3, 3.5. 3 was trained on about 175 billion parameters. GPT-4 is also equally very powerful. Now, how does this model get trained? If you imagine on the far right side here will be the World Wide Web of everything the internet has. If you think about this as real time, the news, websites, this is your World Wide Web. GPT has been trained on the World Wide Web. This is now real time. So the knowledge here could be a little bit stale compared to what we have on the World Wide Web. So let's go back and fill in the other boxes. Think about this as a chat is a subset of GPT. And what does it give us? It gives us attention. For most users who were introduced to large language models through the chat experience, ChatGPT is what we know. But ChatGPT builds and leverages GPT behind the scenes. That's the whole reason for ChatGPT. The chatting experience is a subset that gives attention. It can remember your prompt and give you the results, but you can entirely use GPT without the chat. I will illustrate that here shortly. Below is another very important API from OpenAI, the Embeddings API. Now we'll talk about what the Embeddings API is and how this is useful if you're going to extend beyond just using the ChatGPT. This is a very high level schematic lay of the land for what's available within the GPT ecosystem. So what does this look like for the users? Let's think about the different scenarios. A user on the right, sending an input, This input could be a query. GPT API will give a response back. Very typical scenarios. This is what folks used to use. I used this quite a bit before the chat experience came. This was going directly to the GPT API, putting your questions and getting a response. Now user 2, this is another scenario, going to chat GPT API with an input. The beauty of the second approach, with the response, you can follow up on that response and there will be some retention, which is what the chat experience added. It has more capabilities to remember the questions and then follow up on your prompts. Third key approach, Embeddings API. To get a good appreciation of the embedding API and why that is useful, we have to define what an embedding is and understand what that is. You can give an input to the embedding API and you're going to get a number result back. Those are things we're going to unpack in future lectures. Just to recap what we've seen in the lecture here so far, OpenAI is very powerful. OpenAI is the organization behind this. A little bit of a history here, started by Elon Musk and a group of other folks. Elon Musk left the organization after a while, and OpenAI really took off. Part of what the OpenAI has built is a series of large language models, which is called the GPT, Generalized Pre-trained Models. Beyond the GPT and the chat experience, OpenAI also has the Embeddings API, which is relevant for building and customizing applications leveraging those large language models. We're going to touch on all of this in the next series of lectures, so just check out on the next video for the next concept. In this lecture, we're going to take a look at the GPT API. We'll take a look at the user interaction flow and then go into the pros and cons of using this particular API for use cases. Previously, we saw the Embeddings API, Chat API. From a user perspective, we can have a question from a user, something to the effect of a 50th birthday ideas. Pose that question to the GPT API. I can give you an answer of 10 things to do to celebrate your 50th birthday. Very powerful. Now, here is where it runs into a challenge. If you wanted to follow up, say, elaborate on number 4, because you should remember what number 4 was, to elaborate on it. If that's your question, elaborate on number 4, there will be a problem from that API because it doesn't remember. There's no retention. This is where going directly to the GPT API as opposed to the chat API becomes challenging. This gives us the immediate pros and cons of this approach. One pro could be it's very customizable. Customizable in the sense that you're not having to deal with the chat experience that OpenAI has put on top. You're going directly to the API, you get your response, and you can control how you integrate that response back to get further response. Because you have the control, it could be more flexible for some, but it could also be restrictive for some other folks. The cons, obviously, there is no retention. The API doesn't remember what you said. You ask a question, you get a response. Your next question, you have to give it all the context for that question to be answered. There is no remembering what you said before, which is why folks would tend to love the ChatGPT because of the memory. It can retain what you said and follow up based on that. So very powerful. Now, here is just a quick overview of the GPT API. Now, in the next lecture, we're going to talk about how the ChatGPT API flow looks like. In this lecture, we are going to take a look at the ChatGPT API from OpenAI. We're going to look at the user flow interacting with that API. And we're also going to take a look at some of the pros and cons of using the ChatGPT API as opposed to the GPT API directly or the Embeddings API. If you take a look at what the user interaction will look like. So we have a user who wants to interact with OpenAI using the ChatGPT API directly. The utility of this particular model, again, is how you can ask and answer questions. You come in with your prompt and it gives you a response. But why and how is this different than going directly to GPT? Let's take a look at a couple of flows that could happen. A user come in with a question, if 10 birthday ideas. Maybe you're celebrating your 50th birthday and you're looking for ideas on how to have a good time with that. In this case, we'll go into the ChatGPT API. You get a list of 10 ideas. The next follow-up to that could be, can you elaborate on number 4? You want the AI to take number 4 and to unpack that some more, maybe tell you how to celebrate, go to bowling, go out with friends, go hiking, whatever makes sense. Because there is context, because the API remembers what you said from above, talking about birthday, by simply saying elaborate on number 4, it can come back with something to the effect of good choice. Here is how you celebrate number 4 and give you the specifics. You can obviously continue with more questions around that. And so this is the chat experience that is provided by the ChatGPT API, and it has retention to it. It remembers what you said within this chat box, and it can follow up on that. But behind the scenes, it still uses the GPT API. If you went directly to GPT API, you're going to lose the retention. If you want that retention, then you're going to have the chat experience. So obviously, the pros here, if we're going to enumerate that, would be retention is one. There is continuity as well in the conversations. As with all the OpenAI and the GPT, ChatGPT, the challenge with this is there is no new knowledge. What we mean by this is you cannot get real-time knowledge with this. So if something is breaking, someone has posted an article online, because this model hasn't been trained in real time, you really cannot get that. That's one con to think about from this perspective. But there is a great difference going with the ChatGPT API as opposed to the GPT API or even the Embeddings API. In this lecture, we talk about embeddings within the large language model space. This would be a jumping stone to talking about the OpenAI Embeddings API. What are embedding? From a very higher level view, an embedding is a mathematical representation of a text. If we have a text, a word, a sentence, a paragraph, an essay, or just any corpus of information written in language textual form, and we want a mathematical representation of that in numbers, that would be an embedding in the simplest term. Let's take a look at what that really means, as well as some examples of an embedding. As part of this, we're going to touch on a vector space and a vector search. To understand embeddings, we're going to take a look at some examples of what it means to take a text, to have a mathematical representation of that, and what we can do once we have a mathematical representation of that text from a large language model perspective. To do that, we'll take a look at some examples. We have 6 words listed on the screen. Now, let's do a simple embedding of this word by giving it a mathematical representation and then seeing how this mathematical representation could become useful. To do that, I'm going to assign some numbers to it, and then we'll explain why we assigned the numbers that we did. For a dog, let's assign a number. Let's convert a dog in a textual form and give it a mathematical representation, which is a number. In this case, I'll give it the number 15. And we'll explain why 15. Then the puppy, 23. Canine, 26. Pet, 34. Tree, 41. And notepad, 52. So the act of us taking the word and giving it a mathematical representation is what would be an embedding process. Taking some text and through some rigor or through some process which is repeatable, we've assigned mathematical representations to it. So whenever we do multiplication, subtraction, or any algebra on these numbers, if we see the number 51, then it's a dog. If we see 23, it's a puppy. That process of going from a text to the mathematical representation is an embedding. And this is not a stochastic process. So this is a process that is pretty repeatable. If you give a dog, because the embedding is a mathematical formula, it would always give us 15. You cannot have a dog to 15 and 22 at the same time. That wouldn't be consistent, and that wouldn't be a true embedding. So whatever embedding algorithm you use, should take you from one textual representation to another textual representation in a consistent way. All right. So this is embedding notation or representation. Now, OpenAI has an embeddings API. You can give it your question, you give it your text, you give it your input, and the result of that will be the mathematical representation, some form of a number. Now, why is this relevant for us to have the ability to embed or to encode, whatever term you use, text to get the mathematical representation? Let's touch on that. Go over here, take these mathematical representations and represent that on a number line, or what in the industry will be called a vector space. This is a simple two-dimensional vector space. In the real world, the examples are more rigorous, talking about an n-dimensional vector space that's more advanced and complex than this. So we know how to plot things from simple algebra on a vector space. Let's go ahead and draw a number line, the x-axis, the y-axis. Is pretty straightforward. Now, because the embeddings we use here in our example was pretty trivial, and it has 2 digits, put in a comma there, those were actually pairs of numbers which we intentionally assign. If we have a pair of number that is pretty consistent, we understand how to represent that on the two-dimensional vector space. Take that example, a dog, 1, 5, represent that on a vector space. First one, the number 15, map this will be 1, 5, 6, okay? Now, these are representations of numbers sent through the Embeddings API. So, what does this allow us to do? From a visual perspective, it's illuminating. For one, we're seeing some clustering, which it's not obvious by looking at this. That's why having a mathematical representation becomes so you can apply mathematical rigor and pull insights that you just cannot from pure text. What are some of those insights? Again, if we take a look at this, let's do some simple clustering around the embeddings on the vector space representation. Cluster around this, because there is an obvious clustering here from a Euclidean distance perspective. Here is clustered, here is clustered. Again, just by drawing intuition from it, it all makes sense why this is clustered. Here there is a dog, puppy, pet, canine. That's all similar. So there is some similarity. This takes us into cosine similarity and a whole lot of conversations, which we're not touching on that for now. But that's the intuition and insights we can pull. On this side is obviously a tree and a notepad. There is a similarity here we can pull. Now imagine this wasn't just a dog, a pet, a puppy, and we were building an engine for recommendation. And somewhere in that engine, we saw that the customer was talking about puppy. Now, we know that if they're talking about puppy and we do a search, a grid search or a vector search, this is where vector search comes into play. We do a vector search around what is close to puppy within this vector space. We're going to see a dog, a pet, a canine. Depending on the distance we allow, we are not going to see a tree and notepad. Now we can do a vector search and pull out the similarities around puppy. Same thing with notepad. If we do a vector search to say what is close to notepad within the vector space, we can see a tree. Makes sense. Maybe notepads are made from paper, which comes from wood, which comes from a tree. There is a similarity there. Kind of drawing a little bit of a longer line, but there is a similarity. More so of a similarity than the similarity between a notepad and a pet. Unless somehow within the literature a pet eats a notepad or destroys a notepad, then yes, you can draw a line. But just by simple illustration, a notepad is close to a tree as opposed to a pet or a puppy. So having an embedding has exposed us to a couple of concepts. One, which is a vector space, the vector search. In future demos, we're going to hear about the vector database or VectorDB, and this is where that comes into play. Because if we have an embedding as such, where we have a bunch of text, we call the Embeddings API, get the embeddings, the mathematical representations, we store that into a vector database. It's a specialized database. The reason why that's a specialized database is because it allows you to do things like a vector search. You could pick on a key and say, give me a search around that key for similar words. Now, could you do this in a regular database using regex and strings? Sure, you could, but vector databases are optimized for these types of searches, taking into consideration the semantics of this. Because we did not provide the semantics. What does semantics mean? Semantics means meaning to something. So all we did, if we go back here, was we called the OpenAI Embeddings API. We give it a word and it gives us a number. How did OpenAI decide what number to assign? It does so using the large language model engine because it understands the concept. If we get that number, there is some meaning behind that. There is some semantics behind it. That's the reason why, even though we got seemingly random numbers, when you plot that into a vector space, you start seeing things like a pet and a puppy and a dog is clustered and closer to each other more so than a notepad and a tree. That heavy lifting has been done for us by the OpenAI embeddings model. We can do the clustering as such manually because we can visually see this. But if you have thousands and thousands and thousands of text, you're not going to be able to visually plot it as such, especially when you talked about a vector space, which is more complex than this and multidimensional than this. In that case, you're going to want to throw that into a vector database. There are tons of vector databases out there. The popular ones now are PineCone, many players that are coming up in space building vector databases. There's Weaviate, Postgres vector database. This is something you're going to see more and more in the industry. And the vector database is specialized to storing these embeddings to allow for vector search. And that vector search takes into consideration the semantics of the data, so the meaning of the data. And this data could be your product data, your products catalog, or whatever data set it is that you've used for the embeddings. It will give you that semantics on top of it. So a very powerful concept to understand what the embeddings is. And this is a foundational concept that becomes relevant for folks that are, or teams or product leaders that are building applications on the open AI. So this is one example. Let's take a look at another simple example here just to illustrate this embeddings concept because it's a very powerful concept before we jump off to other areas. Coming back here, let's do example 2 for an embeddings perspective. So with this example, we are going to go a little bit more than we did in example 1. Here we had just simple words, and the argument could be made that when you interact with OpenAI, you don't give it simple words. You ask questions. You give it sentences. You give it paragraphs. That's the power of OpenAI. That comes here too as well. Start with a couple of sentences we want embeddings around. The first one here would be around football, American football. That's a sentence. All right, so this is a complete list of our sentences. Just to recap, football is the first, wolf is the second, feline says friend, meow as a cat. Each of these sentences, we're going to take this, send that to the Embeddings API, and we're going to get back a mathematical representation, some form of a number. Assume we've done that already. We took that to plot that in a vector space from a visual perspective. Ideally, you're not going to be plotting this. You're going to be putting that into a vector database. So you can do vector search on it. Here, A would be down here, plot that. C and D might be somewhere up here. This is the plotting of the embeddings we've gotten by simply running each of this through the Embeddings API, and whatever number we got back, we've plotted that out on the vector space. As before, the idea here is to draw intuitions and insights that we cannot do just by looking at the text. Doing a simple vector search, I can do clustering around here. So clustering here, if I'm doing a vector search on this item, I can do a simple vector search around here. Or you can even do, depending on what the query is, you can do a vector search around these 3 items. Now, what are these 3 items? B, E, and F. B, E is what? B was wolf. E is my sister's, is as smart as, and F is a computer. All right, so my sister is as smart as a computer. It makes sense. Now, why does wolf show up there? Not necessarily obvious, but it might be my sister is as smart as a dog. Now, that would not be a nice thing to say, obviously, but there is semantic meanings to it, which is why we can see that within the representation. So very powerful, very illustrative in terms of understanding what an embedding is. Let's do a quick recap here. We've seen a lot of examples, two really good examples. An embedding within the world of large language model is a mathematical representation of a text. OpenAI has an Embeddings API. All it does is give it some text, a word, sentence, a paragraph, whatever you send to it is going to give you a mathematical representation. That mathematical representation is not just junk, it's numbers that have meanings to it. If you do some mathematical exploration of the numbers you get back, there are insights to be drawn, and those insights could be showing you similarities as such, showing you which items are related to which other items. And these are things that organizations or users would want to use, especially if you're building an application, send an email to your customers. You want to know what products to recommend to them, maybe based on other products they've bought, and having those embeddings and insights all stored in a vector database where you can do a vector search becomes very popular or very powerful. PineCone, Weaviate, Snowflake, and many other database vendors are all building solutions specific to a vector database, so you can do a vector search on the vector database, which is something traditional databases do not do. So if you've heard of a vector database, this is where it really comes into play. In this video, we will touch on the Embeddings API provided by OpenAI. OpenAI provides a number of APIs, GPT API, ChatGPT API, as well as the Embeddings API. We'll touch on the Embeddings API here, what the workflow from a user perspective would look like. Now, if you're not familiar with what an embedding is, would highly recommend you check on the channel in this series we're doing and watch the video about embeddings, what they are. These are mathematical representations of a text. OpenAI provides an API that allows you to take a text and an embedding around that text. Going back to the trusted capability box, we had a user can interact directly with the ChatGPT API, and you're going to be touching this point, which is a subset of the broader GPT API. Alternatively, a user can send requests directly to the Embeddings API, and this will be a response. If we recall from the definition and the explanation we did around embeddings, again, I'll highly recommend you check out that video. If you haven't watched the video about an orientation on embeddings, you can send a full sentence like, what should I do to celebrate the 50th birthday? Now, this is a text. It's not just a simple word. Even though it's a text in the form of a question, there are certain key semantic components in here. Celebrate 50th birthday. And the OpenAI Embeddings API would take all of that. It's going to do an embedding of it. So it's going to convert that to a mathematical representation and return something to the effect of, and this is not exact, we're just doing an illustration here, maybe 5, 7, 6, 9, 2, 4, 1, 8, 4, 6, 7, 1. It might be a longer string, but this is a number. It's a mathematical representation of this. The beauty about this is when you have numbers, you can apply mathematical rigor to it in terms of doing search, plotting this to a vector space, doing vector analysis on it, and really pulling insight. All of these are illustrated in the video we've done around embeddings, vector spaces, vector databases. So if you need some ideas on that, links will be left here somewhere on the video. Check on that as well as in the description as well. From an embeddings API, you can go to the Embeddings API to get a mathematical representation of your text, your questions, and those mathematical representations encode information that becomes very relevant when you pull that into a vector database to do vector searching. This lecture would be a finale to the series of lectures we've done around large language models. There are a lot of concepts we've touched on in this lecture. We've talked about OpenAI, the 3 main APIs available from OpenAI, the GPT API, the ChatGPT, the Embeddings API. We've also looked at embeddings as a concept and why that is relevant. In this lecture, we're going to put all of that together into a cohesive reference architecture and how this all plays from an enterprise landscape. As part of the discussion, we're going to touch on LLMOps plus context learning. That said, a simple box that looks like this. And the 3 main components we saw, one was the chat component, which is the chat API, GPT API, the Embeddings API. So these are the three main APIs that we've referenced as part of OpenAI ChatGPT. Somewhere on the far right side is the web. Training happens between OpenAI and the web. For most users, the workflow would be very analogous to a user either using the API to talk to chat and having a chat experience. Alternatively, go directly to the GPT API. Last but not least, going to the Embeddings API. Now, why isn't this sufficient? Why don't we stop at this point and close the conversation? Well, it really comes down into how do we take what is available and the power of this large language model and bring it to a context that's relevant to answering questions that OpenAI is not exposed to. OpenAI has been trained on the web, but it hasn't been trained on your company's data. It hasn't been trained on your specific data and the insights that are available to your specific enterprise data set. To illustrate that, let's go ahead and introduce a new box. This box would be your traditional enterprise data warehouse. It's been a mainstay for many organizations. It's pretty secure, and organizations have no incentive to take that and hand it over to OpenAI. But somehow we still need to have exposure to those insights so we can customize, we can learn as we interact and write questions to OpenAI. For illustration purposes, this box could have some records. Number one could be football, a pen. These are just data sets that are available within your enterprise data. Now, what does a workflow that takes into consideration this enterprise data look like within the landscape of OpenAI and the ChatGPT interface? Let's take a look at what that looks like. Now we have a user here on the right side. Unlike the user from below, this user on the right is not going to talk to the APIs directly. That's not going to happen. So we're going to have to introduce a new application, a new interface. Here, let's build an app that this user would talk to. And you're going to see a lot of this coming to market. Many smart folks are spending time building these applications to take advantage of the power of ChatGPT and models. Now, as a user, your query goes into this interface as opposed to going to OpenAI or ChatGPT directly. If a user poses that question, there are a couple of things we can do. We can take the question as before and send that directly to ChatGPT and get a response. But we are going to lose the context that is available within the enterprise data warehouse. We want to capture that context when we interact with the language models. So in that case, instead of just posing a question to ChatGPT, let's take that question and send that to the Embeddings API. Call the question A. So A goes to the Embeddings API. Now, if you're not familiar with what the Embeddings API is, I would recommend we spend time laying the foundation on that. Just watch that video. It's a very comprehensive video. It will give a good introduction into what embeddings are and why the Embeddings API is relevant. The Embeddings API, for summary, it takes text and it converts that into a mathematical representation of numbers. Those numbers have meanings to it. There's some semantics tied to those numbers. That said, take our question, we send that to the Embeddings API, and the Embeddings API will give us a result. Ordinarily, we'll take the result and we'll put that into our data warehouse. But there is a problem. If you remember from that discussion around embeddings and the discussion around that, embeddings provides a number of unique characteristics. It's a vector result that comes back. You want to do vector search. In that case, a vector database is really what you need than what the traditional databases typically would provide. Here, we need a vector database. For this, I'm going to introduce a new store here to persist our result diamond. Make this as the vector database. So this is our vector. Let's do that in red. This is our VectorDB. Now, there are many players in this space from a vector database perspective. I'll just give some ideas here. from a VectorDB. Many players are positioning themselves. There is PineCone, is a popular one. There is Weaviate. Postgres has something around Vector. I think it's called Postgres Vector, Snowflake, and many players are all positioning themselves. What will be very interesting is right now, the vector database space is still in the infancy, but not pontificating here. What would naturally happen is that most of these data warehouses are going to respond, and that scope of a data warehouse might expand to include the vector database. Just something to be aware of. And this is what will hold the result from embedding. Once the embeddings happen, let's take those results and put those results into a vector database. Let's call that A prime. So A prime goes into the vector database, but instead of having A prime outside, I'm going to go ahead and put A prime inside the VectorDB. And VectorDB is popular again because you can do vector search. Vector search comes in a number of algorithms. There is a cosine similarity. Facebook has a FIAS, if I'm pronouncing that correctly or spelling that correctly. There are so many capabilities that comes with the vector database, which is why the embedding results will make sense to be in a vector database. Now, if we have the embedding results in the vector database just by itself, we're still missing something because we still don't have the enterprise context that we're looking for. Now, what if we took all of that enterprise data and we bounce that against the OpenAI Embeddings API? Let's call this E, standing for enterprise data. Those results goes into our vector database. So everything here would be embedded to give us the context from OpenAI. Now we have A plus E prime within the vector database. Now this becomes more powerful because not only do we have the question that was asked by the user, but we have the context of what exists within our database in a way that we can now do a search. In this case, we can do a vector search and send the results, called that result R1, back to the application for the user. If you're not familiar with what a vector search is, go ahead and watch the video we've done around that. PineCone is really good at that. Weaviate is good. And many players are responding to having that ability to do a vector search. Ideally, once we get R1 from our vector search, we should, in theory, be able to just present that back to our app, and that's good, or to the interface, and that's good. But guess what? Something is still missing because we asked the question. Sure, we've done the vector search, but that doesn't necessarily give us the answer that we want. It maybe gives us more context, but it doesn't necessarily give us the answer. What we can do now with that additional context is fine-tune the question to make it more contextual, and then we can go ahead and send that to OpenAI. In this case, we're going to introduce another line which goes to OpenAI, to ChatGPT, or to GPT, depending on which one you're using. This will be R2. Now we had R1 here, and we're going to send R2. This whole idea of taking R1 and tuning that to give you a very specific question to ask is prompt engineering. This is where the heavy lifting of prompt engineering happens. Now, when folks interact, if we go back here and you have users that are saying and sending queries back and forth, there is some prompt engineering there happening, but not to the level at which you can do within our context here. Now, you do some prompt engineering because you have additional context than A, talking about our prime that has been contextualized for the user. Now we have a result that can then be returned to the screen. This result now would be R3. So you send R2 to ChatGPT, and then ChatGPT now gives you R3, and R3 is what the user gets to see. This space is the active space that the industry is innovating around. This is what it means to take those large language models and bring to enterprises. You might hear of LLMOps, which are built from DevOps or data ops. There are so many ops. LLMOps is what the industry is talking about. That all comes into play from a contextual perspective, bringing that to light. There are many tools in this space that are relevant for just the idea of prompt engineering. Let's just zero in on this here, this piece, the prompt engineering. So you hear of LangChain is another tool that is coming up. There is Haystack, Llama Lab, Llama Index, there's GPT Index. There are so many players. LangChain is powerful because it allows for prompt templating. I will do some videos and maybe demos about LangChain in the future. There are agents and connectors to different sources. It has memory similar to what ChatGPT has its own memory, but as you're going through this back and forth, you need some form of memory and retention too as well. LangChain is providing templates around that. So many things in this space. That's just from LangChain. Then for tokenizing the data, it uses a BPE, the byte pair encoding. GPT Index is another one, another tool to watch out for coming up in this space. FICE is an algorithm, obviously, from Facebook that helps with the semantic search within your vector database. Obviously, there is a Llama Hub. We cannot forget that. Llama Hub, Llama Index, or Llama Lab. So many tools and players in this space. But the whole idea for this reference architecture discussion is to orient around this. It could be a little bit mysterious for someone who always uses GPT this way to then imagine how organizations are bringing it to their use cases. This is what that reference architecture looks like. To give an example here, and then we're going to wrap up this discussion, would be think about a scenario where the question coming from the app is someone buys a new camper. So let's do a camper here, C. And you generate a question to ChatGPT. My customer just bought a new camper. Send a welcome email to them. All right. If you send C, camper, send a welcome email, ChatGPT will just somehow send you some random email based on what it thinks people who buy camper typically do. It's not going to be personal because that could be for anybody out there. But guess what? You have your database here and you have view of transactions that customers who buy camper, maybe they like football and pens. It would be nice to take that into consideration when OpenAI or ChatGPT is writing that email because it's a large language model. What if you re-engineer your prompt to take into consideration those insights that are available within your database? In that case, what you're going to do is now you take C here, customers just bought a camper. You want to send them an email, you embed that question. We have that embedding here. When we do a vector search will surface to us that, oh, camper, football, and pen are all clustered. There is a relation in there from a vector search perspective, looking at the Euclidean space. Now we have a result where we can then do prompt engineering to say, instead of just sending a new prompt to be customer bought camper directly to ChatGPT, we'll say, send an email to the customer that bought camper, understanding that they like pens and football. Now, ChatGPT is good. If you give it more context, it's going to give you a better response. The second response that you get from ChatGPT in this flow would be more contextualized than if you simply took an input and sent it to ChatGPT, right? Hopefully this architecture makes sense in terms of how this all fits together. It's a growing and evolving space. Many players are staking their claims and trying to build more and more solutions. LangChain, we've talked about it. There is the VectorDBs to allow for those vector searches. PineCone, Weaviate, those are players that are all coming up. Some are startups, some are entrenched organizations. I see it as an inevitability that the warehouses will respond to this. They're not going to stick in this sitting down. They're going to expand so you can do vector searches instead of traditional data warehouses. That wouldn't be surprising. But all of this is a good way to allow for large language model operations and context learning or context Q&A or generative Q&A that the industry is building. So hopefully this was helpful from an orientation perspective. A little bit of a higher level view. Wanted to demystify this and unpack this in case anyone is wondering how this all fits. I'm hoping that this quick walkthrough will give you the foundation. This is backed up by the previous lectures and the previous discussions we've had. Those were all building into this. There's still a lot more to talk about, but hopefully this is a good stepping stone to then go down into more advanced, more tactical discussions and questions to unpack.